In this tutorial we'll have a look at the Boolean operations, which are under the FX tab, and they're this group of functions here. Booleans allow us to combine clips using certain mathematical operations. For those of you that are used to maths or programming, some of these will already make sense, but otherwise we'll just have a look at what they do to pictures. So what I have set up on a timeline are just two simple wipes, slightly offset from each other. So let's firstly look at OR. What an OR function does is it effectively looks at all of its inputs and provides an output where there is something on input 1 or input 2 or input 3 and all the way down. It can have any number of inputs. So as you can see in this situation, we have both of our circles together. If I change this for an AND, which on this particular version of Mistika comes up with multiply, that's a little bit of a naming bug that will no doubt get resolved, but it's because at bit level multiply and AND do the same thing. So now we can see the response here, which is, because we're using an AND operation, only the output that exists in the first input and the second input, and third and fourth and fifth and so on, gets passed to the output. So we can see that what we're getting effectively is the common area between the two circles. Finally, let's look at subtract. And we can see that the second input has been subtracted from the first. So with subtract, the order of the inputs is relevant. The second input is taken from the first. With the last two effects we looked at, OR and AND, actually the ordering isn't so relevant. So we can see here that the circle from the second input has taken a chunk out of the first. So those basic Boolean operations are very useful for example, combining mats, or taking one mat out of another mat, and those sorts of basic operations. They can also be used in compositing as well. So let's look at OR and ADD. In this instance, I've got a background clip and I've got some smoke that's on black. And in fact, OR provides quite a useful compositing tool to be able to do just a very simple overlay where you have something like smoke or mist or steam or fog, that sort of thing, on black. Then the OR operation often gives you the kind of compositing that you'd like. In fact, in this instance, it would be the same as using a Comp 3D DVE with its mode turned to screen. That actually gives you an identical composite. The difference is OR would be faster. So if you're working with high resolution images, then the OR would more likely maintain real-time speed. But of course the Comp 3D has many more tools to be able to position and so on. If we replace that with ADD, we can see there's a subtle difference. You see the smoke has become a lot brighter. So perhaps we can set something up just to show the difference between OR and ADD. If I go back to my circles, this time under Edit, I'm just going to add a nonlinear mix to them both. What that does is, by default, it has a blend down at 50%, so now my circle is half as bright as it was. If we bring up a scope, we can see. So if I now combine these with an OR, we can see that we get a slight uplift in brightness between the two, as we can see on the scope. On the other hand, if I use ADD, we get a much brighter common part, because this function has done a mathematical add between the 50% level of the circles to get 100% where they overlap. Where we might also use these functions with real images might be to add glows. So, for example, I'll take this shot, I'll duplicate it and add a blur. And then I'll or add that back to its original. So I'll start with add. And we can see that what we're getting is a glow effect, because the values of the blurred version are being added to the values of the sharp version. So to control a blur, I could add in one of the color correction nodes. In order to change how much blur we get. If we were to replace the add with an or, then we get a slightly more subtle effect, because we don't get that increase in brightness. Now if we look into the parameters of the or the add or the and, we can see there are a lot of parameters. Now the reason that there are so many parameters is this. Under the Booleans, you can see that we've got the add, or, and subtract, and then something called channels. In fact, all of these are channels. They just have the settings of channels preset to do this operation. So in fact, if you are picking up or add or something for your timeline, the chances are you'll never need to go into these parameters, because they've already been preset to do that operation. If you want to do something else, then that's where channels comes in, and all those parameters. So let's have a look at them now. So going back to our two offset circles, I'll just add a channels. The name of the effect channels refers to the 4 channels that make up an image: red, green, blue and alpha. And so we have a folder for each here: red, green, blue and alpha. Now in fact, we only need to learn one of them, because they all contain the same operations. It's just that one relates to the output red channel, the output green channel and the output blue channel. So if we just open the red one for now, what this is showing us is these are the maths that can be used to take values from the first and second input, to do something with them, and then to create the value that goes to the red channel of the output of the effect. So this top line allows us to do our maths. So we can put 2 values into our maths and choose what to do with those 2 values. So the 2 values are x and y. So at the moment what we can see, value x is set to the value of the red channel of the first input. But we could also choose to take it from the green value of the first input, or the blue, or the alpha, or the luminance of the first input, and then likewise of the second input. And our operation at the moment is x only. So what this is saying is the output red channel of this effect should be the same as the red value of the first input. That's why the output of our effect is identical to input 1. But what we could say, for example, is the output red channel actually should be the red channel of the second input. So now you can see that the result of this is actually to take the green and the blue channels from the first input and the red channel from the second input. Using the operation, we can carry out various evaluations on 2 values. So if I just go to look at the red channel, just so we can see one channel at a time, and I'll put this back to red 1. So at the moment the operation is just the red of the first channel. But turning it to only y would be only this one, which is set to red 2. Or we could say that it's the addition of the 2 channels, the subtraction of the 2 channels, so you can see where those presets have come from. The AND of the 2 channels, as in the union of the 2 channels. Or, just like the effect that we had, there's also exclusive OR. The difference between OR and exclusive OR, again the programmers will know this, is with OR, the output is passed where either input is not black, or not 0 in fact in maths. Whereas with exclusive OR, the output is only passed where a value exists in one input or the other, but not in both. We can also pass the lower or the higher of the two values. So to set something up slightly differently with this, what I'll do is select a wipe and a solid as the two inputs. Then under the wipe, I'll just remove the animation and just give us a grayscale. So you can see our grayscale. Meanwhile, our solid, we can go from black to white with this control. So back to channels, and I'll set the operation to pass the lower of the two. So you can see straight away it's gone to black, because the lower of those two inputs is the black of the solid second input. But as I raise this, we can see on the scope that what's being passed is input 1, but only so long as it's lower than input 2. As soon as it goes higher, it passes input 2. And this evaluation is done on a pixel by pixel level. If I swapped it to pass the higher of the two, then we get it this way round. We can also pass only the difference between the channels, or we can force the channel to be 100% or 0%, or we could divide the two channels. In addition, we can invert this value before the maths. We can invert the final output, or invert this value before the maths. We can also scale our output, or bias the output, which is effectively a blacklift, if you like. And these controls are the same for each one. So at the moment you can see that I've been working with the red channel for the red output. The green output by default will look at the G's, of course, and the blues. So let's look at a couple of practical uses of channels. Here's something that confused me a little when I first had it. It's a graphic where it turned out that the red and the green channels were swapped. So rather than this being an RGB image, it was actually a GRB image, if you see what I mean. And it's one of those things that you hit it with a color corrector and spin things around, and you never quite find the right colors. But this is where channels will help. So if I add on a channels, I now know that the red channel actually needs to look at the green, and the green channel actually needs to look at the red. Now it's looking entirely more reasonable. So that's a simple use of channels, to be able to swap around channels if we need to. In the keying section, we did a tutorial with this shot, where in fact we used channels to provide the difference between the two inputs in order to give us an accurate key for the shadows and so on. So have a look at the tutorial in keying, in compositing keying, for the full way of doing it. But in essence, a way of doing it would be to set the alpha channel to be the difference between, say, the luminance of the two inputs. So now when we look at the alpha channel, we can see we can get something for the shadow and for them. And of course, using the scale and the bias and so on, we can start to fill in our matte. Another possible use of channels is where you want to process one channel differently to the others. As many of you will know, it's quite common that the blue channel in digital files, or indeed from film, is actually the noisiest of the channels. So let's just take this shot. I'm just going to make it a lot brighter just so we can see what's going on. Just look at the noise pattern in here. So if we look at the green channel, there's some noise. If we look at the blue channel, there's a lot more noise and compression artifacts and all sorts of things. So of course I could denoise this. And actually, if you do use the denoise function, have a look at the manual, because it takes you through the proper process of getting this perfectly set up. But I'll just do it quickly for now. So what I have at the moment is I've denoised the whole shot. But let's say I only really wanted to denoise the blue channel, because that's where the trouble lies. What I could do is duplicate the original non-denoised shot and then use channels, making sure that the blue channel is set to look at the second input. So now if we do the same thing again by making the image a lot brighter, so we can bring out the noise. So that's now just looking at the blue channel. And if we swap it between channels, so that was the original, and now that's a denoised channel. So channels and its presets add, or, and subtract find plenty of uses as you start to work with Mistika. Their use might not be immediately apparent at first, but they provide some very useful functions for combining mats and those sorts of operations. But also remember that channels evaluates on a pixel by pixel level, so putting in different images and playing around with the maths on the channels can create some pretty interesting looks. It's certainly one of the functions of Mistika worth knowing about, and playing around with some images and values to see what you get.